Homework policies. Homework will be assigned every Friday and will be due the following Friday, and all homework assignments will be posted online. And for most um, weeks, you'll be expected to have 4 different things possibly happening at once. The homework that's based on the Monday, Wednesday lectures. There's homework based on the certification exam preparation. There'll be the Friday presentations and a class project. And actually, this is a typo. There's only one class project and not 2 class projects. I do expect homework to be written up carefully and neatly. Basically, if you're the instructor, which would you rather read? Would you rather read the stuff on the left, or would you rather read the stuff on the right? I don't expect War and Peace, but I do expect homework to be written up neatly so that the homework grader is able to read your work carefully and without straining her eyes. Okay, all homework assignment will be posted online, so let me show you what that looks like. So the homework assignments, you'll have homework for Monday and Wednesday, certification exam review, questions for Friday, and also class projects. So on January 18th, this set of problems will be due based on the lectures. Also, on the same day, the certification exams problems will be due. So let me show you what the certification exam looks like. The certification exams, certification review, basically looks like problems that I've given to my previous pre-calculus and calculus classes back in the days when I taught TAMS pre-cal and calculus. In fact, the problems that you see now appeared on their exams that I gave in the past. So these are real pre-cal and cal problems. And the idea of these problems is to refresh your memory about these topics from pre-calculus and calculus, because I know it's been a while since you've thought about those topics. And a great portion of the state certification exam is going to be on these, topics that are not hard, but you just haven't seen in quite a while. So each certification exam, or I shouldn't say exam, each certification review has something on the order of 12 to 15 problems. This one has 13 problems. And I expect you to turn in 5 of these, 5 of your choosing. So choose any 5 problems that you wish. But I do expect you to write a statement saying that you've at least taken a look at all of the problems, even though you're only turning in 5. That doesn't mean you've solved all of the problems, but it just means that you've taken a good look at each one of them, and you think you have some idea as to what the problem is asking. So that's written up here. At the top of your write-up, you must write a statement saying that you've at least thought about all assigned problems, and points will be deducted if you do not write this statement. So that is there's actually 6 problems on each of these homework assignments, the 5 that you turn in, and the 6th problem is the simple one saying that you've at least thought about all these problems. And I would be my preference that you're honest when you write this, that you have indeed thought about all these problems. This will occur every single week. So the first few problems, certification reviews 2, 3, 4, 5, 6, 7, and 8. I believe 8 is the last one on the topic of pre-calculus. So the problems that you see here are on pre-calculus topics. And then starting in week 9, we move to topics on calculus. So that's a little bit about these certification reviews. The idea is that you're reviewing these topics that you've learned long ago, but you just haven't probably seen in a while. Okay. The third thing that will happen are the Friday question and answer sessions. So questions for Friday, if I click this, what you see here are a bunch of questions taken from mostly mathematical questions from the classroom. Also some questions from this article that appeared in 2011 by this article that appeared in the notices of the AMS. And also some of the questions that appear here are questions that my own students have asked, or sometimes even my daughter has asked me. And basically, for these sessions, I'm giving you the questions, and I will call students at random to the board to answer them. So I'm giving you the questions ahead of time, and I will call students at random to answer them. Now, the grading rubric for this, everything here will be peer graded. This grading rubric is basically based on my old high school speech class. There's not a whole lot to it. There's 7 parts: preparation, knowledge of subject matter, communication, eye contact, volume, time, and stage presence. The two most important ones are preparation and knowledge of subject matter. If the presenter was unprepared, that's a 0, and then that's an automatic 0 for the entire presentation. Knowledge of subject matter, if there's a limited understanding of the subject, then that deserves a 0, and then don't even bother with the rest of the rubric. In other words, it doesn't matter how good your communication, your eye contact, your volume, your time, or your stage presence. If these top two things are not there, all the others are meaningless. So, that's the grading rubric. Now, for all the others, you can get 2, 1s, or 0s based on the opinions. Now, notice that there are 7 categories. 1, 2, 3, 4, 5, 6, 7 categories. So if you get a 2 on all of them, that's a 14, and then I want that rounded down to a 10. Okay, so I did this on purpose. The grading for the Friday presentations will actually be peer graded. So you will be judging your peers on how they did on their Friday presentations. So I put this way on purpose so that you can give somebody a 1 or a 0 on a couple of categories, and they can still get 100 on their presentation based on your perceptions of how they did. And I'm doing this on purpose so that you can be honest with your feedback. If somebody didn't do something that was spot on perfect, you can give them a 1 and it doesn't affect their grade. And I think honest criticism is going to make everybody a better teacher someday. So I'm doing this on purpose so that hopefully you have some good feedback about how you're doing with the Friday presentations. And so basically the way this will work is that everybody will grade everybody else, then the forms will get passed back to me, and then I'll collect the scores, put them in the grade book, and then I'll return those the following class period. All presentations will be peer graded, and I believe I put on the syllabus that if you really mess up a presentation, you're permitted once during the semester for a second chance session to be scheduled with your instructor. So at such a session, it might be one-on-one, it might be 2-on-1 with other people that need to make up a session. I'll give you a list of questions, and then you will actually answer multiple questions, and you'll be directly graded by me for those second chance questions. So if you really blow one, you have a chance to make it up. The other part of the homework is going to be the class project, and the class project concerns various ideas that are used to engage students with the secondary mathematics curriculum. So for example, the first part of the project will be due on January 25th concerning topics in either pre-algebra or else probability and statistics. And the list of topics can be seen over here. Let me pull that up for us. So the list of topics for this first session will cover, say, order of operations, field axioms, reducing fractions to the lowest terms, scientific notation, in statistics, stem and leaf plots, expressing probabilities as fractions or percentages, probability and odds, histograms, using the binomial distribution, using the bell curve, using the normal distribution. So these are topics that appear in real life, honest to goodness, high school textbooks. And your job is to come up with top ideas for engaging your students. So I'm not looking for a full 5E lesson plan. I'm looking basically for the first E. What can you do to engage your students? And I've given 5 different possible things that you could use for engaging your students. First off, applications. What interesting word problems can your students do using this topic? And the operative word here is interesting. We don't want any questions along the lines of Farmer Jones is building a fence. He's got 120 feet of fence. How can he make the fence to enclose the maximum possible area? That is contrived. No real farmer is going to be doing that, and there's especially on a field that isn't going to be perfectly flat. So what interesting word problems can you do? And you might look at various websites. I've given you one idea, spacemath.nasa.gov, for ideas. Feel free to suggest others. A second application is, how could you create an activity that involves this topic? Your topic might be along the lines of curriculum. How can this topic be used in a future course, or how does this topic extend what they should have learned in previous courses? So this is taking a look, kind of a vertical look at the curriculum. C, culture. How has this topic appeared in pop culture, or maybe high culture, or maybe how has this topic appeared in the news? You can also come up with engagement topics involving history. What interesting things can you say about the people that contributed to the discovery or development of this topic? How is this topic adopted by the mathematical community? How did people's conception of this topic change over time? And what are the contributions of various cultures to this topic? So kind of a historical way of engaging students with the topic. And finally, another way of engaging students would be with technology. So how could YouTube, Khan Academy, Geometry Sketchpad, ViHart, calculators, whatever, be used to effectively engage students with this topic? And by that I mean, don't just say such and such is a great website. You need to explain in some detail why you think it is a great website. So the idea of these questions is to make you think about ways of engaging your future students. This list of questions is not necessarily comprehensive, and you're welcome to suggest another question if you have a really great idea that doesn't somehow fit into one of these questions that I have on the page here. So there will be 4 parts to the class project. Let me show you that here. So there's 4 parts to the class project: pre-algebra, problem and statistics, and then algebra 1, algebra 2, then geometry, and finally pre-calculus. And I've tried to space them out so that they're in between the exams. So for all 4 parts, you will be expected to answer with 3 responses. So 3 questions for each of the 4 parts for a total of 12 responses. By the end of the semester, I expect you to pick at least 1 question from all 5 categories. So you can't just simply pick the history topic or only the application topic. You need to pick things eventually from all 5 categories with the 12 responses that you'll provide throughout the semester. Your responses are not expected to be terribly long, but just a paragraph or 2. You're not expected to come up with something terribly original as long as you cite your work. And topics will be chosen on a first-come, first-served basis, so be sure to ask your instructor, me, for your top 5 or 10 choices, just in case somebody's already taken up your favorite topic. So your work should be submitted by email as a Microsoft Word document. So john_doe_13.docx would be the way that you should save your file. And also you should write out your topic. On the website, I've provided some exemplary projects from the past. So this was a project that involved inverse, converse, and contrapositive, which are seen in geometry class. And this particular first one was chosen using Monty Python. Next topic involved advertising. And the next topic involved basically Alice in Wonderland. So these are very creative ideas for trying to engage students with the topic of logic using these ideas from pop culture. Another idea was from using equations of a circle. And so first topic, it extends the idea of the Pythagorean theorem. It also extends the idea of using sines and cosines. And then it came up with a fairly interesting problem using a transit of Venus, which occurred on June 5th, 2012, and using the equation of a circle to be able to solve a problem involving the transit of Venus. So I put this up here so you get an idea of how I want the work formatted. You can see it's not the longest project in the world, but it's quality. By the end of the semester, what I will be doing is compiling all of these things and providing it back to you as a class. So you're going to be writing a manual basically for your classmates as to various engagement topics for the secondary curriculum. And I hope that this will be something that will be helpful to you when you begin your career as a secondary teacher. The projects will be based on be graded on 3 things. Is your information accurate? Does your information engage a decent portion of your students? And will your peers be able to understand your work, which includes references? You don't have to cite things in APA format, but you do have to write things in such a way that your classmates will be able to clearly understand what you have written. So those are the major portions of the class. So Monday, Wednesday lectures, which is going to be more like a standard math class. Fridays will be certification review or else test days. So that's the question for Fridays. There will also be the certification exam preparation problems, and finally the 4 parts of the class project.